So you did zoom and you did 6. So it went and changed your window to negative 10, 10, negative 10, 10. Okay? So that zoom 6 gets you to this window, the negative 10, 10 window, and a scale of 1. We're going to change that in a little bit, but that for right now, that's the window we want to start with. Okay? Now you're going to go into your y equals and you're going to type in x squared into your y equals. So you're going to press your top left button, the y equals button, and then to get x, you press the x t theta n button. It's below mode. Towards the top, it's the x t theta n button. It looks like this. You press that button and it'll give you an x. And then press squared. So now you should have x squared in your y equals. Okay? Press graph. Be quiet. You're just punching this into your calculator. So you get y equals x squared. Okay? And you press graph and it draws it for you. Now if you go second graph, it'll give you your table of values for you. So go to 0, 0, and then we're going to work our way out. So we have 0, 0. Then we have 1 and 1. Then we have negative 1 and 1. 2 and 4. 3 and 9. Negative 3 and 9. Negative 2 and 4. Okay, connect those, and you have your parabola, your quadratic function. And label it y equals x squared. Yeah, you're supposed to draw it. So you pick the coordinates off your table of values from second graph, and then you have your points, and then you connect them and draw them. 0, 0, 1, 1, negative 1, 1. And parabolas, quadratics are symmetrical. So if you actually folded them on the axis of symmetry, the line down the middle, which we're going to deal with axis of symmetry soon, you would get the exact same graph on both sides. Then in your y2, so in your y1, you leave the x squared, you guys, okay? Into your y2, so you're going to arrow down, you're going to put in 2x squared. So put in 2x squared. Don't press graph, just press 2x squared for now. So in your y2, you're going to have 2x squared. Okay? Once you have 2x squared in your y2, you're going to arrow all the way over to the left until you're on the diagonal line. So you're going to arrow all the way over to the left on your y2 until you're on the diagonal line. Everyone there? Press enter once. So you're going to arrow all the way over, and don't press graph is what I said. So you're going to go arrow over all the way to the left on that blinking and hit enter. Okay? Now you have it thicker, which it should be. Then press graph. Now you know that the second graph drawn on there is the thicker graph. So now over to the left, onto this diagonal line and hit enter. Now press graph. So the thicker line is the second one, okay? Now go second graph. I'm just going to put it right there. Not far away from you. You'll be fine. Okay. So you're going to go and you're going to press second graph. Second graph. And now you're going to have another table of values. The x value is always the first one, and now you're going to pick the x value with the y value from the second one, right? No, you're good. So you're going to take the x value from the first line and the y value from the y2 column, and that's going to be your points, your coordinates for this new graph. So you still have 0, 0, and then you have 1 and 2, negative 1 and 2, and then you'll have 2 and 8, and negative 2 and 8. pretend this for you. You don't have to do it because you're getting outside. So this one here is y equals 2x squared. What happened to the graph? It got thinner, it got narrower, right? So go to your y2, keep your y1, keep your x squared there. Go to your y2 and clear it out. Now when you press clear, it's going to clear off that thicker line as well. So you have to redo that, but that's okay. In your y2, now put 1/2 x squared. And remember, we always just put fractions in brackets, just in case. So whenever it's a fraction, please put it in brackets, okay? Always, fractions go in brackets. So in your y2, you're now going to put in 1/2 x squared. Make it a thicker graph and press graph and see what happens. In your y2, you're going to put in 1/2 x squared, just like this. And then you're just going to... Yeah, you don't want that shading. You don't want it to do that. So then press graph. You have to put in half first. You didn't listen to me. Clear that out and put... You just want to stay as a thick line. Yeah. It doesn't matter as long as you know. I usually make y2 the thicker one. So all we're doing is in y2, we're clearing out y2 and we're typing this into y2 in brackets, just like this. Okay? If you're lost, type that into y2. And then press graph so you can see the two graphs. Did you clear out your y1? There you go. Okay. Don't clear out your y1. Okay, we're drawing a half in. So this is going to go down here. This is going to go down here. This is going to stay here. And 4 is going to pop down to 2. 9 pops down to 4.5. And then you label this graph. It's y equals 1/2 x squared. What happened to the graph now? We always compare it to the original red graph. What happened? It got wider. So always make your y2 the thicker one, so you know what that is. Yeah, there's no point in doing that. Okay. So we have those. So what can we say? What can we determine about this? When the a value is greater than 1, what happened to the graph? The blue graph is the one a got greater than 1. It narrowed, correct? And then when a was between 0 and 1, so like a half, what happened to the graph? It got wider. The reason why is it's going to take longer to go upwards because all the y's are being halved. And the blue one went up faster because all the y's were being multiplied by 2. So we're going to flip to the second page just for a second, then, or to the next page, then we're going to come back. So when we have a positive number greater than 1, what happens? A positive number greater than 1. What happened to the graph? It got narrower. So when a was greater than 1, the graph became more narrow, or became narrower. A positive number less than 1. A positive number less than 1 means that a is between 0 and 1. If A is between 0 and 1, what happened to the graph? It got wider. Let's you have that flip back to the graph. So in your y1, you're going to keep x squared again, but in your y2, you're going to put negative x squared. You're not going to put subtraction x squared. You're going to put negative x squared because this isn't a subtraction sign. If you put subtraction x squared, it's different. So put negative x squared into your y2 and make it thicker. I'm just going to put it right here. So what happens to it? It's a reflection in the, which axis do you think? In the x-axis. Okay, so basically every y of the red is negated. So when it becomes negative, we actually get a concave down parabola. Now, what do you think is going to happen when it's negative 2? It's going to make it down, but narrower, just like the 2 did to the other one. It made it narrower, but it's negative 2 this time, so it's actually going to make it down and narrower. And then this is going to make it the exact same as the black graph, but downwards, right? That's all that happens. Okay. Yes. Hello. Hello, children watching this podcast. I have, but I won't mention names. I mention names the whole time. It doesn't know that. Matt's period 3. No. This is like the fourth time today I've gone wrong class. Basic X quadrant. I apologize. As you were on your problem. Okay, so this one just ends at the exact same, you guys, but reflected down, right? So really, what we have to know is that the number in front, if it's between 0 and 1, it makes it wider, whether it's down or up, correct? The number in front, if it is greater than 1, makes it narrower, down or up. And the only thing that changes whether it's up or down is just this sign. The sign makes it reflect in the x-axis, so it makes it go down. Okay? So let's flip to the next page. So a negative number. A negative number causes a reflection in the x-axis. If it's a negative fraction between 0 and 1, it's going to be a reflection in the x-axis and wider. If it's a negative and it's greater than 1, or I guess less than negative 1 technically, it's going to make it narrower and reflect. Okay? So really the number in front makes it narrower or wider, and then sign in front makes it up or down, is the end result. So that's just the A value in front. There's also this Q value at the back because we're looking at the standard form. not standard form, the vertex form. It's ax minus p squared plus q. Okay? We've looked at the a. The a gave us a reflection in the x-axis or not. So it caused the graph to be down or up or wider or narrower, right? The q value is the number at the back. Some people think it's with the x. This is not with the x. X squared is right here. There's nothing with the x. It's in its own bracket, actually. There's nothing with the x. This is a number at the back, the q at the back. Okay? Let's look at what happens. So in our y1, we still have our x squared. So let's draw that first. It's at 0, 0, 1, 1, negative 1, 1, 2 and 4, negative 2 and 4, 3 and 9, negative 3 and 9. So we get our y equals x squared graph. Alrighty? All of our graphs are compared to this basic y equals x squared graph. It's just any graph that has anything added onto the x squared is just a transformation, just a movement of the x squared graph. So this is our y equals, our y1's going to have x squared still in it. That didn't change. In our y2 now, we're going to put x squared plus 4. Put that in and see what happens. X squared plus 4 in the y2. Because you're always comparing it to the x squared. There's no point. Yeah, it wouldn't matter. What? Okay. So we have y equals x squared. When we have y equals x squared plus 4, what happened to the graph? What was the change? Went up 4. What do you think is going to happen with this one? Down 3. So if we move this graph up 4, 1, 2, 3, 4, 4, 4. So this will just move up 4. This move down 3. The whole graph. This is called a vertical translation. Because it translates the graph either completely up or completely down. If you don't have a q value at the back or any value at the back, then you have no translation. That's all. Now, keep in mind these graphs, this equation is written in f of x, this. It could be y equals x squared minus 3. Or I could write it like this, y plus 3 equals x squared. Keep in mind that whenever it's with the variable, you always do the opposite. So here it's y plus 3, so I actually move down 3. If the 3 is just at the back, it's not with the y anymore, then I do what it is. So if it's minus 3, then I go down 3. If it's with the y, it's plus 3, I go down 3. The same thing. It's just opposite when you're with the variable. So keep that in mind. Very important, especially in grade 12. So if we know this stuff before going in, we're ahead of the game. Opposite movement when you are with the variable. So when it's with the y, it's plus 3. That means I move 3 down. So our a value stretched our graph out or in, right? Our a value, if it was negative, it reflected it down or it was concave up. Our q value is a vertical translation. So it's either moving it up or moving it down. Okay? What do you think the p might do? The p value? Side to side. So once you're done writing this, flip to the next one. So here we have comparing the graphs f of x equals x squared to f of x minus p squared. So keep our x squared in our graph calculator. So 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, 3, 9, negative 3, 9. So y equals x squared. Then in your y2, put in brackets x minus 2 bracket squared. I press graph. What does it look like happened? Shifted which way? Right or left? To the right 2. So this goes 2 to the right. This goes 2 to the right. This goes 2 to the right. Same y values, just 2 to the right. This is y equals x minus 2 squared. Take that one out and put in x plus 1 squared. What does it look like happens? Which way? How many? 1. So it shifts from the original x squared 1 to the left. So y equals x plus 1 squared. Now, what did I tell you to write on the previous question? When it's with the variable, you move the opposite direction, right? So the x, it will always be with the x. I can't, like with the queen, or the queen, funny, queen starts with q. With the q, I don't know where queen came from. With the q, if it's with the y, you do the opposite. But if it's over on this side, right, and it wasn't with the y, then you do what it is, okay? X, I can never move. It's always with it. So you always go the opposite direction, okay? This is a horizontal translation. The other one was vertical. This one is horizontal. It's a horizontal translation. Now, flip over here. Describe how the graph changes. It moves right or left, basically. If it's x plus p squared, it moves left. If it's x minus p squared, it moves right. When you're done that, we're going to look at the bottom. Okay, important stuff. Okay, so this is in vertex form. Y equals a x minus p squared plus q. When in vertex form, you can find the vertex. The vertex is just what p and q are. So let's write an example here. Y equals negative 3x plus 2 squared minus 7. Okay? For this example, p would be actually not 2. P would be negative 2. Now, the reason why that is you guys, the vertex form has x minus p squared, correct? So in order to get plus 2, this would have actually had to have been x minus negative 2 squared. That's the only way that this would have worked. In order for it to be in this form, I'd have to have x minus a negative 2. That's why it is actually negative 2, not positive 2 when you take out the p-value. Okay? So it's going to be negative 2 and negative 7. This one doesn't change because it's plus q. So this would be plus negative 7. So negative 7 would be q. So the vertex is at negative 2, negative 7 for this example. The axis of symmetry is what cuts the graph in half. So if I were to draw this graph at the value negative 2 and negative 7 would be my vertex. The vertex is the minimum or the maximum point. Would this graph actually be like this? No, why? This has a negative a value. What does the negative a value do? Makes it go down. So it's a concave down parabola at negative 2, negative 7. This example, correct? Now the equation of the axis of symmetry would be the, like, you remember how you guys in kindergarten or grade 1 you'd make hearts and you like fold the paper in half and you cut out half the heart and it would open up? That fold line is the axis of symmetry. So it's the axis that cuts it in half. So this would be at x equals negative 2, the p-value of your vertex. So for this one, it would be x equals negative 2 for this specific example. Now, is this graph concave up or concave down? Concave down because my a was negative. I don't care that it's a 3 at all. The only part that makes it be concave down is that sign that's in front of that 3. Okay? So it's concave down because this one is negative. Is this a maximum or minimum? It's a maximum. Now, the way to tell if it's a max or a min, you guys, I always just pretend there's a little dude walking along this path. So if there's a little guy and he's walking along and he gets it all the way to the bottom, is he at the minimum of this valley or the maximum? Minimum. People tell me it's the max all the time. It's not. It's minimum. And if I put a little dude and he's climbing up to the top of here, he's at the maximum. He's super happy. So this one is a maximum. Now, maximum value is based on only the Q. The Q tells you how high or how low. Why? Is the Q the X or the Y? It's the Y. So it tells me that actually on this graph, the highest I went was negative 7, right? Or my graph keeps going lower, but the highest it goes is negative 7 because that's my maximum. Okay? So this one would be a maximum at negative 7. The domain for every quadratic, unless it's a word problem, is XER because it keeps going on forever and ever and ever and ever, either way, this way or this way. So you can find every X value on that graph, there's a corresponding Y value. And if that happens, it's XER. Now, interval notation would be for XER, means that every value exists. So if I drew the number line for XER, it would be the entire number line, correct? Because every X value exists for it. So if I do interval notation instead of set notation, which was X such that X is an element of reals, if I do interval notation for this, which you would have done last year, This little arm represents negative infinity, correct? So we do negative infinity, and we do a round bracket, because you can never equal negative infinity. You can't equal infinity of any type. Infinity is an idea. It's not an actual specific number. It keeps going on forever and ever and ever. So you can't actually equal infinity. So you do negative infinity with a round bracket. Then it covers every value in between up to this arm, which is positive infinity. So XER in interval notation is negative infinity, comma, positive infinity. Negative infinity to positive infinity. So up here, I could write, instead of doing set builder notation, which is x such that x an element of the reals, I could write it as negative infinity, positive infinity. And you need to be able to do both. You need to be able to do interval notation. The range is a little harder because it just depends on if it's up or down. If it opens up, my range is going to be y is greater than whatever the heck my q value is. Because whatever my q value is, that's the lowest it can be or higher than it. So that's your range. Y such that y is greater than or equal to my q value if it opens up. If it opens down, my range is going to be whatever my q value is less than that value. So y is less than or equal to q. And we'll do interval notation when we do some examples on the next page. So those are all the important things: the vertex, axis symmetry, direction, max min, domain, and range. Okay, we're going to flip to the next page. All right. So we're going to look at the equation here first. The very first thing I do before I answer any of my questions is I will type it into my calculator. Okay? So type this into your calculator, but before you type into your calculator, actually tell me if it's concave up or down. Why? Because there's no negative in the front. If there's no negative on your leading coefficient, it's concave up. You go punch into your calculator and look at it. Y equals 2x squared plus 1. Yeah. You can just put it into your Y1 now. So, you gotta stop. So the vertex of this equation, y equals 2x squared plus 1. The vertex of that is the p and the q. What's the p in this equation? Y equals 2x squared plus 1. I can write this as y equals 2. What's with my x? Nothing. X plus 0 squared plus 1. It's how I could write it if I want to. Because there's nothing with my x, right? It's just by itself, so x plus 0. So my vertex is just 0. You're not going to say negative 0. I know you want to take the opposite sign. 0 is neutral, so you just call it 0. So this means I moved it 0 right or left. So my vertex is at 0 and 1. Because you take the opposite of this, keep this. But when it's just 0, it's just 0. 0 doesn't have a sign. What's my axis of symmetry? It's always the x of the vertex. So as long as I have my vertex, I can answer it. It's x equals what? 0. This is always x equals p. Vertex is always p and q. With the equation y equals a x minus p squared plus q. What's my domain of every single quadratic on this page? Yes, x and element of the reals. So the domain is always the x value. So it's going to be x such that x and element of the reals. Or I could write it as negative infinity, positive infinity, round bracket with a comma in between. You don't have to write both, but it depends if it's a multiple choice or if I ask for interval or set notation, then it does matter. Now the range, go look on your calculator. This is a concave up graph, right? So is there a low minimum value or a high maximum value? There's a low minimum value. What is the lowest value? No. What's the lowest y value? 1. The lowest y value is 1. It's what your vertex value is, right? So we know that our range is going to be y such that y is greater than or equal to 1. Because I can't go any lower than 1. 1 is the minimum I can go. The rest of my graph is higher than that. The range is what values of y exist on this graph. Well, 1 or higher, because there is no graph below 1. So it's y such that y is less than or equal to 1, yer. How do I represent, greater than or equal to? How do I represent greater than or equal to 1 in interval notation? I'll go down here and look at it. No, I'm going to stay up here. Okay, y is greater than or equal to 1. How the heck can I represent that in interval notation? Treat it like it's a number line. How could I represent y is greater than or equal to 1 on a number line? Draw 1. It's equal to it, so I have a closed dot. And it's greater than it, so I'm this way. Right? So if I draw this as an interval, it's between 1 and what? What is this arrow always? Infinity. So this can be between 1 and infinity. Infinity has a round bracket. 1 could have a squared or a round, depending on if it's equal to or not. Is it equal to 1? Yes, because 1 is down here. It's obviously equal to it. So we have a square bracket. Square means equal to, round means not equal to. So it's equal to 1 to positive infinity. We're going from 1 to positive infinity because it's greater than 1. So we can write that as positive 1 to infinity round bracket. So it looks like this, 1 to infinity. Number 2, what's the vertex of number 2? What's my p-value? What's my p-value? It's with x. So -1. The p-value is what's beside your x, and remember it's always the opposite because we have this minus sign here, right? And what's my q if there's nothing at the back? 0, because we can put a +0. So my vertex is at -1 and 0. If this is +1, we write -1 because it's x minus p, the formula. What's the vertex of number 3? Is it negative or positive 3? Positive 3 and positive 2. So we change it if it's with the variable, we keep it if it's not. So this is with the variable, we change it. It's not with the variable, so we keep it. This is a positive 5. It's with the variable, so we're going to write -5. And then +0 is at the back, so -5 and 0. What's this one? What's with my x? What's with my x? Nothing. So my vertex is going to be at 0 and -1. What about 6? 0 and 0. And what about this last one? +5, and what's the back? 0. Because you have to take the opposite of this. Because remember, it moves it 5 to the right. because of the x minus p, because there's a hidden negative in it, we always have to take the opposite, because this would be x minus a positive 5. So that's what we take 5. So my axis of symmetry is just my x value, correct? So this one's going to be x equals -1. This is going to be x equals 3. This is going to be x equals -5. X equals 0. X equals 0. X equals +5. Yeah, because it's an equation. It's a 0? Oh, what circle? It's an equal sign. It's just squishy. Then the range. The range is easiest to determine if you actually put in your calculator, because you can kind of see it. Okay? So punch this one into your calculator. 2 bracket x plus 1 bracket squared. Everyone put in your calculator. Y equals 2 bracket x plus 1 bracket squared. Is it concave up or concave down? It's concave up. It's concave up because we have a positive a value in front, right? Anyways. So is there a minimum value or a maximum value? Minimum value. What is the lowest value? 0, right? It's right here. 0. So the minimum value is 0. Okay? So we're going to say y is what 0? Is it greater than 0 the rest of the graph, or is it less than 0 the rest of the graph? Look at your graph. Is the rest of the graph above 0 or below? Above. So we're going to say range y such that y is greater than or equal to 0. YER. And if it's greater than 0 or equal to it, it means from 0 to positive infinity. Put number 3 in your calculator. Yeah, you must be missing the squared if you got a line.
So yeah, if you put 2 bracket x plus 0 plus 1.
Yeah, you just missed the squared is all. Oh, I get what you're saying. No. Plus 2. Putting in number 3 into your calculator. And trying to get the range. So the graph is concave up because we have a positive 1 in front of here. Because we have a positive 1 in front of here, our graph is concave up. Because we have a positive a value, it's concave up. So what's do I have a low value or a highest value? Do I have a minimum or a maximum? I have a minimum at 2. So I'm going to say y is greater than or equal to 2, or y is less than or equal to 2. Is the graph all above 2 or below it? All above it. So we're going to say y such that y is greater than or equal to 2. YER. And if it's greater than 2 or equal to 2, I have a square bracket because it's equal to 2 all the way to positive infinity. You guys try 4, 5, and 6, and 7. 4, 5, 6, and 7. Just the range, because what's the domain always? X.